Hello, this is a live stream of the solution of the final exam. So I'm gonna do it in about the same way as usually in the class, which means I am switching between the visor screen. Okay, let me see if where the okay, there you go. So I'm gonna switch between the visor screen and also a PDF viewer. So this way I can look at both screens at the same time. Not exactly at the same there we go. Okay, so I'm not sure whether the audio was dropping out before or not, but basically, I'm just repeating myself. The audio part is it's not that important. Okay, so for question number 3, it's kind of the same thing. The instruction says right here, comment and explain what each line does according to what is outlined in the section labeled important. And if a register or stack content is initialized prior to this section of code, indicate so and explain the value of the register or stack content prior to this section of code in high-level C construct. So I need everything to be explained or related back to C construct. All right, so this is an easy one. We are allocating stack space. And we know it's not a local variable because we're putting something into it right away. So now the question is, what is in register A? Now, what is in register A is done in the previous question. So if you go back to the previous question, on line 54 here, register A has PTR, or the value of the parameter. So we can go back here and say the same thing. So we basically say A is PTR from, I think that's question 4. Okay, so we are now pushing PTR on the stack. And then the next line is the reference. So because A is already PTR, when we dereference, A becomes whatever PTR points to. Okay, and then we decrement D again. Now the important part here is whatever PTR points to is the beginning of a structure, but that is also known as PTR points to the member L, because that's the first member. So this is the tricky part, and if you just answer whatever PTR points to, you get partial credit. But if you identify that we are using the member L of what PTR points to, that's the full mark. So once again, we are allocating stack space here, and this time we are storing A to wherever. So we are pushing whatever A has, but because A is a member L of the structure pointed to by PTR, we are now pushing that thing on the stack. And now A is the return address. Allocate space on the stack, and this is basically effectively pushing the return address. And then we continue in called subroutine, and this is the return address where we're supposed to return to. And then increment D is for allocating the PTR, the pointer or the parameter. So either way is fine. If you want to say the allocate PTR param, that's fine. If you want to say the allocate PTR, that's fine too. So that's kind of what I'm looking for here, is to relate it back to C code as much as possible. And the identification of member L of what PTR points to is particularly important. Now that part is really important because back in the C code, okay, so let's go back to the C code here. Oops. Okay. So getting back to the C code, you can see that in the C code, the structure has L being pointed to a struct X, and the parameter is expecting a pointer to a struct X as well. So that's why it is important to recognize that we are not pushing the first byte of the structure. We are pushing the first member of the structure on the stack. All right, so let's move on to question number 4, which is kind of the same deal, except this is a later section. Okay. All right, so Now we have to identify what we are popping from the stack on line 66. Now, line 66 obviously is a continuation. Oops, you cannot see that. Switch to, there we go. Okay, so line 66 is a continuation. This is line 66. It's a continuation of line 65. So the question is, what is on the stack now? Now we push two things on the stack. The first thing we push on the stack is this thing here. We push PTR on the stack. The second thing we push on the stack is the member L of whatever of the structure pointed to by PTR. That was popped here, but not this. So when we get to this statement here, we'll have to say pop PTR from stack, because that's what we pushed on line 56. So the next line is adding A to A, but A has the return value of calling traverse with the member L. Okay, so we are now basically calculating twice of that. So after this, it becomes the return value times 2 because we are adding A to itself. And then what we're doing here is we're overwriting the stack. So it is kind of the same thing as popping and then pushing back on. So it's kind of pushing 2 times traverse of PTRL on stack. Except we never really changed the stack pointer because otherwise it would just be an increment followed immediately by a decrement. All right, so now that we know what B is, okay, because B is PTR, okay. So the next thing is, what is B now? Well, it is 1 byte pass what PTR points to. So that would be the address of the second member. So now it is the address of the second member of the structure pointed to by PTR. So the second member is, I think, V, or the value. And then next one is the address of the third member, which is R. And over here, we're doing a dereference. So when we dereference the address of member R of the structure pointed to by PTR, we get back just member R of the structure pointed to by PTR. Decrement D, that's always just allocating some stack space. Okay. And then we are storing that. So we're pushing PTR R on the stack as parameter, because that relates to C construct. The concept of a parameter is a C construct. Okay, L4 is a return address, so A is a return address. Once again, we are allocating stack space, and effectively we are just pushing the return address on stack at this point. And now we continue execution in callee, or if you prefer, the subroutine. This is our return address for this particular call, and we are now deallocating. Now, it is correct that it is just incrementing D, or D is increased by 1, but that does not relate it back to C construct. So the best way to say this, because I ask to relate it back to C construct, is to say this is deallocating the parameter, the space used by the parameter on the stack. And then the next one is saying, okay, so we are popping something else on the stack, because after we deallocate the parameter, there's something else on the stack. That something else on the stack was done on line 68. So whatever we push on line 68 is now retrieved. So that is 2x traverse PTR L on the stack. So now B is 2 times the return value of traverse using the L member of the structure pointed to by PTR. And then we deallocate pushed to X traverse of PTR points to L. And now we add B to A. So what is A at this point? So A automatically has the return value of the last function call. So as a result, at this point, A, because we add B to A, so A is now 2 times the return value of traverse called on PTR points to L, and traverse of PTR points to R, because that's the most recent call. So that's kind of what I'm expecting for question number 4. Moving on to question number 5. So question number 5 is asking, based on listing 2 and all of the previous questions, disassemble the whole thing. Okay, so what I'm going to do is I'm switching back to the browser, okay, so that I can identify which part we're talking about here. So I can always copy and paste the prototype, which is this part here. So I'm going to copy that here. So we got and traverse, whoops, typo here. And we are passing a pointer to a struct X on the stack. That's our parameter. Okay. So switching back to, so this is the beginning. And now what we need to do is to figure out what is next. Well, we know the entire thing has one single control structure, which is a conditional statement. All right, so we say if, and from question number 2, we know it is identifying whether PTR is null or not. So you can say if PTR, or you can say if PTR does not equal to 0. Either way is fine. And if that is the case, if PTR is non-null, we go through all that big chunk of code which specifies a return value of 2 times so here's a return 2 times traverse of PTR points to L plus traverse of PTR right. Now this question is slightly different from the Wednesday class. So for the Monday Wednesday class, there's a subtraction involved instead of 2 times. But the idea is kind of the same. But there's actually a third component that is not a part of the previous questions. So let me point out which portion we're talking about here. Just press the wrong key. No. Okay. So let me switch back to the browser. Okay. So the third part is something that is not disassembled in earlier attempts. And that goes from line as an alternative to this answer, so for those of you who like to use a ternary operator, then it is like this. Okay, so I'm putting everything on the same line. It is return PTR question mark, and then we have 2 times which are PTR left, expression from the third expression of a ternary operator. The else value is just a 0. Semicolon that ends the return statement, and curly brace that ends the def function definition. So that's the alternative. Alright, so that's question number 5. Question number 6 is, assuming that you got question number 5, or you got an idea of how it works. So let me read the question here. According to listing to what are the return values of the following calls based on the structure initialized with digits of your student ID? Okay, so this part is, I made a little poo-poo here as well, because the C code and the assembly code is off a little bit. So if you go by either one, it's fine. Okay, I'm not gonna be picky. Okay, so when you look at the assembly code or the C code, okay, so I'm just gonna use the C code as a reference. So when you look at C code, N1 is at the top level because it refers to N2 and N3. N2 refers to N4 and 5. N3 refers to N6 and 7. And N4 and 5 and 6 and 7 do not refer to anything else. Okay. So you can either build a tree, to look at it this way, or you can just look at the disassemble program to figure out what it's going to do. So let's go back to here, and if you look at the disassemble code, if PTR is 0, it's just going to return a 0 here. See, when PTR is a 0, it's just going to return a 0. So in this case, x is just going to get a value of 0. Okay, so the other one is N6. So N6 does not refer to anything else. So even though it does do the recursive call, but both recursive call to the left and also to the right is not going to give it any value. It's going to give it a value of 0. So it's 2 times 0 plus 0 plus the 6th digit. So in my student ID, which is 0008776, it'll be an 8. There we go. N3 refers to N5 and 6. So it is going to be 2 times my 5th digit. Let's see, my 5th digit is, I need to write it down here, 0006887. This is 1, 2, 3, 4, 5, 6, 7. So it's going to refer to 5, so it's 2 times 8 plus, think about this again. So N5, I just forgot how I made the structure. So N3 refers to N4, N6 and 7. Okay, so I got it wrong. 6 and 7. So 6 is still good. Okay, so N6 is 8, which is this 8 here, and 7 is 7. So this 8 goes here, this 7 goes to here. But we also have to add the value of the third digit itself, which is a 0 in my case. Your case is probably not a 0 because I start course, I can plug in my code to see if it runs correctly. Now, remember I said a little bit earlier that there's a discrepancy between the C code and the assembly code. And we can find out where the mistake is. So that mistake is, I'm just going to highlight each part as well. It has to do with this part. See how N3 and N2 are reversed? So that means, when you give me the answer, I will have to accept that one as correct as well. So that means with these numbers, so the alternative answer is 2 times 23 plus 20 plus 0, because I'm just reversing this 20 and this 23. Okay, so instead of multiplying the 20 by 2, I'm multiplying the 23 by 2, and then instead of having the 23 by itself, it is now 20 all by itself. So now we have 46 plus 20, which is 66. So in this particular case, using my own ID, 63 or 66 are both correct answers. Now, if you show me the calculation and it reflects that you understand the structure of the program, but you got the calculation wrong, you will still get some extra credit. So so this is just demonstrating. This is just showing you what is the correct answer. The exact point value of each part is not determined. I can guarantee you that all the questions carry the same weight, but in the question, how I allocate the points and whatnot, that part has not been determined yet. So I'm hoping that you guys will understand the solution, and I'm designing this particular exam so that there are partial credit along the way. So even if someone cannot figure out, all the way to question number 5 or 6, hopefully the earlier portion, which are very, very similar to the solution of the last homework assignment. So hopefully most people will get points from just observing my solution to that particular homework assignment and just kind of more or less, copy and paste the comments. Question number 5 and 6 are a little bit harder because you have to put everything together, especially question number 6, which basically requires you to understand the overall control structure first before you can actually, kind of figure out, how to compute these individual values. So anyway, this is it, and I'm gonna terminate or turn off OBS at this point. And if you have any questions, go ahead and ask me. And once again, the Monday-Wednesday class, you guys have a different equation because we are subtracting. There's a sub AB instead of add. So instead of add